All right. So the next set of rules is rationalizing, removing a radical from the denominator, because you can never have a radical at the bottom of a fraction or in the denominator, because then it's not simplified. And so we have a tactic to get rid of that radical at the bottom. Um, and basically, that's just rationalizing the radical, the radicand, in the denominator by multiplying the numerator and the denominator by the bottom radical. Get rid of the radical on the bottom. So one way to look at it is whatever is at the bottom. Each time you have a radical that's at the bottom that is not a perfect square, then you're going to rationalize it using that radical at the bottom. So our radical at the bottom is the square root of 7. So I'm going to multiply the top and the bottom by the square root of 7 to rationalize it. Now, the reason why we do this is because this will not change our original fraction. Square root of 7 over square root of 7 is the same as if you would think of 4 over 4. 4 over 4 is 1. 1 is your multiplicative of anything. Anything times 1 remains the same. So I could say 7 or the square root of 6 over the square root of 7, and I multiply it by 1, it's still going to be the square root of 6 over the square root of 7. Well, I could change that 1 and write that 1 as 4 over 4. Well, 4 over 4 is still going to end up giving me the square root of 6 over square root of 7, but I want to change it so that I don't have a radical at the bottom. And the easiest way to do that is to multiply the numerator and the denominator by that radical at the bottom. By doing that, you get rid of the radical. Remember, inmates and outmates don't mix, but these are both inside, so this is going to leave with you the square root of 42. And the square root of 7 times the square root of 7. Well, some people want to go ahead and write the square root of 49. Well, what's the square root of 49? It's 7. So you can skip that step and just have the square root of 42 over 7. And then the square root of 42, that's as it's divisible, it's going to get. Being, well, 7 is prime, one of the prime factors, and 6 and 2. 6 can only be divisible by 3 and 2, or 6 in itself, so we are done right here. Now, if you have a radical over, we can't have a fraction inside the radical symbol or underneath the radical symbol. So what we do is we separate them. And once I have it separated, then I can determine how I'm going to rationalize this, because I can't have a radical at the bottom. This cannot stay. So to get rid of the radical, I'm going to multiply the top and the bottom by the square root of 2 over square root of 2. Remember, whenever you multiply a radical by itself, you're just going to get rid of the radical and be left with the radicand, what's inside the radical. This will be left with 30. And that cannot be simplified any further. No perfect square goes into 30. So we're done here. So on 42, to get rid of the radical at the bottom, we're going to multiply the top and the bottom by square root of 6. Well, this 2 now is not inside. It stays outside. So you have 2 square root of 6 over 6. And now the 2 and the 6 can be worked together and be simplified to 1 square root of 6 over 3. Or 1/3 square root of 6. It's the same thing. So the key thing you have to remember, is that you never can have a radical, no radical, at the bottom. And whenever you do, you have to rationalize it, multiply by the radical, by the denominator radical, to get rid of the radical at the bottom. So on here, to get rid of the square root of 5 at the bottom, I'm going to multiply the top and the bottom by that square root of 5. Square root of 5 over square root of 5. It simplifies 3 square root of 5 because over 5. And that's my final answer. So once you try to simplify 44 and 45. And I'll put the answer up here. So I'm just go ahead and pause the video and then come back and see if you get the final answer. Here, the 3's can be canceled out, or 3 over 3 is the same thing as 1. So hopefully you got those right. On the next section, we're going to look at how to use cross multiplication and using our properties with multiplying and dividing to solve a proportion dealing with radicals. So here, we're going to just cross multiply like we did last semester and then use our radical rule. So when I cross multiply, this is going to be 8 square root of 2, or 8 times the square root of 2. 8 is now the coefficient, is equal to 4. And we're solving for x now. So when we normally solve for x, we're trying to get the x by itself. So to do that, I'm going to divide by a radical 2. That will cancel that out, leaving me with just x. But can I keep my answer as 4 over radical 2? No, because you cannot have a 4. You can't have a radical 2 in the denominator. You can't have this. So we're going to rationalize it to get rid of the radical in the denominator. This will leave me with 4 radical 2 over 2. And I know 2 can go into 4 2 times. So I am left with x equals 2 radical 2. Okay. Same here. We're going to cross multiply. X square root of 3, or radical 3, equals 6. And then we're going to divide both sides by the square root of 3. There is a pattern here. After you do it several times, you can see a shortcut. You cannot leave this as your answer because you can't have a radical at the bottom, so we're going to rationalize it. So this is 6 square root of 3 over 3. And again, 3 can go into 6 2 times, leaving me with 2 radical 3. So whenever you have proportion dealing with the radical, you are going to just solve proportions like you have in the past. So here we're going to have 2x equals 3 radical 5. And then we're just going to divide both sides by 2. So x will be equal to 3 square root of 5 radical 5 over 2. And now I can leave that because 3 and the 2 are both on the outside or outmates, and they cannot be reduced any further. So once you try 49 and then check your answer, go ahead and pause the video. All right, so that's rationalizing and cross multiplying using your radical rules to simplify and solve for a variable. Check out the next video dealing with Pythagorean theorem with radicals and its Pythagorean converse. And that will wrap up the notes. Make sure you do the ones I haven't done.